Hi everyone, ngayon naman, let's try to solve material balances involving reactions pa rin, but this time utilizing all the three methods that we have discussed. So we will have extent of reaction method, and then let's do it again using atomic balance, and then finally, let's use molecular balance method. So in this problem, you have formaldehyde produced industrially by the catalytic oxidation of methanol by the following reaction. So we have methanol and oxygen forming CH2O and water. Unfortunately, under the conditions used to produce formaldehyde at a profitable rate, a significant portion of the formaldehyde can react with oxygen to produce CO and H2O. So basically, parallel reaction sila. Assume that methanol and twice the stoichiometric amount of air needed for complete oxidation of the methanol are fed to the reactor. That 90% conversion of the methanol results, and a 75% yield of formaldehyde occurs based on the theoretical production of CH2O by reaction 1. So the goal here is to determine the composition of the product gas leaving the reactor. Now, yung mga statements na nandito sa problem, mahalaga sila. Let's kind of emphasize them a little bit. So sabi dito, ang finifeed mo sa reactor ay methanol, which I have shown here in the flow sheet, and yung air. Now, sabi dyan, ang air is twice, okay? So, twice the stoichiometric amount needed. Ibig sabihin, kung gaano kadami yung kailangan ng air sa reaction, doble nun ang ipapasok natin sa reactor. Okay? Ano pa? Sabi rin dito, 90% conversion and 75% yield. Okay? So let's try to answer this problem. Unang-una, nasulat ko na dito yung composition of feed. So we have methanol and air being 21% oxygen and 79% nitrogen. By what? Diba? By volume sila or by moles, no? Okay. Now, for the product, ano yung mga species na we can expect? Of course, yung mga product from reaction 1, that's CH2O and water. And also yung product from reaction 2, which is carbon monoxide. Okay, water nandiyan na. And you will also expect na may matitirang methanol, oxygen, and nitrogen. Okay, so therefore we will have the following unknowns. So we need to compute for N1. So ito yung mga ina-assign kong variables now. Hanggang N6. Okay, so there will be 6 unknowns in this problem. Okay. Basis tayo. So let's solve this one now. A good basis perhaps will be what? Kung ano man yung meron tayo na given. So let's probably have, well, we are after the composition of product. So siya yung pinaka-unknown, yung product composition natin. Yung feed, wala siyang given na amount na pinasok. Okay, so therefore, mag-umbento tayo ng basis, sabi natin 100 moles of methanol yung ating pinasok. Okay? And assuming also that the limiting reactant is ethanol. Okay. And that makes sense because for oxygen, which is one of the reactants, dinoble natin yung stoichiometric amount needed. So probably oxygen here is an excess reactant. Okay. Let's first calculate yung moles oxygen theoretical. Ano ibig sabihin? Pero meron tayong 100 moles na methanol. So methanol pala to, no? So we have 100 moles of CH3OH. But based on the reaction, ilan yung theoretically required na amount ni oxygen. So ang stoichiometric relationship kasi nila, for every 2 mole of methanol, 1 mole daw yung kailangan na oxygen. So saan ba siya makita? Dito sa ating reaction. Reaction number 1. Kasi 'di ba, for every 1 mole of methanol, 1/2 daw yung oxygen. So simplifying that, 1:2. Okay? So therefore, 50 moles. Yung theoretical amount ni oxygen na required. Kaso, hindi yan yung ipapasok natin. So we have to compute the moles of methanol fed to the reactor. Sabi sa problem, twice the stoichiometric amount ang kinakailangan. So, multiply natin yan by 2. So yung 50 moles na na-compute natin, doble niyan yung ipapasok natin sa reactor. So 100 moles therefore yung ating oxygen. And we're also interested dun sa amount ni nitrogen fed to the reactor. Eh, alam naman natin yung composition nila, di ba? So kung 100 moles yung oxygen fed to the reactor, for every 21 moles of oxygen, 79 moles yung nitrogen. So this will become 376.19 moles of nitrogen. And if you are interested, okay, the total moles of air fed is just the sum of 100 and 376.19. So 476.19 moles of air. Okay, so nakumpleto na natin yung amounts ni oxygen and nitrogen na pinasok sa reactor, and we already have an amount of methanol fed to the reactor kasi we have a basis. But before we go to our methods, merong given kasi na conversion. Okay, dun sa problem. And the conversion given in the problem is 90%. Okay? So naalala nyo paano kumuha ng conversion, di ba? F is moles reacted divided by moles fed. So 0.90 or 90% yung fractional conversion natin. Moles reacted is what? Paano natin mahanap si moles reacted? So we don't have that value for now, but we can calculate that or express that bilang si moles reacted ay kung ano yung natitira minus kung ano yung pinasok. Right? Moles after minus moles before. But yung moles after, okay, again, by the way, no, ang conversion na tinutukoy dito is conversion ni methanol bilang siya yung limiting reactant natin. Now, ano ba yung methanol dun sa ating flowchart? So si methanol, it gets the symbol N4. Tama ba? So therefore, N4 is the final. N4 minus initially methanol is what? Sorry, baliktad. Initial minus final dapat kasi mas marami syempre yung initial kaysa kay final. So initial moles ni methanol is 100, but yung final niya is N4 according to our flowchart, divided by the initial or the fed. So using the conversion alone, nakuha na natin agad yung amount ni N4. Okay? So usually pag may mga given na ganyan, yield, conversion, selectivity, you will be able to get some of the unknowns, and the rest should be calculated using the methods that we discussed. So N4 is 10 moles therefore of CH3OH or methanol. Okay, so done yung N4 natin. Ano pa? Meron din tayong yield. Okay, so for the yield, which is, ano bang given na yield? Balikan lang natin saglit yung ating problem statement. So yung yield dito ay yield of formaldehyde. Okay, so let me kind of highlight that. Ang nakalagay daw na yield is yield of formaldehyde. Ito si formaldehyde. Based on the theoretical production of formaldehyde reaction 1. Ibig sabihin, yung yield na tinutukoy dyan is we just have to focus on the reaction 1. Okay, ano ba ang ibig sabihin ng yield? Diba? Pag sinabi natin yield, let me write that down in equation form. Yield is moles of the product obtained, okay, or actual obtained, divided by moles of that particular product theoretical. Okay, diba? Among the three definitions of yield that we discussed before, the third one is the most commonly used, actual over theoretical. So let's do this. Ang problema nga lang, we don't have yet this part, yung moles of CH2O theoretical. Pero madali lang yan. Kasi, anyway, let's just substitute right away. So the yield given from the problem statement is 75% or 0.75. Yung moles formaldehyde obtained, di ba? According to our variables, we name that as N1. Okay? So maya-maya, makakuha na natin yung N1 na yan. Divided by moles of CH2O theoretical. Paano natin yan makukuha? Wala naman tayong given yan. So what you can do, if you go back to reaction 1, okay? Again, pakita natin ulit. So si reaction 1, ang relationship ni methanol kay formaldehyde is 1:1. Methanol being our limiting reactant. So, since we know or we have a basis for 100 moles of methanol, gawin mo lang yung 1:1. Okay, yan na yung 100 moles then therefore yung kay formaldehyde. So therefore, you will be able to compute N1 as 75 moles of formaldehyde. So out of the 6 unknowns, na-compute na natin yung dalawa. So 4 na unknowns na lang yung ating kailangang i-solve. Okay? So dito mag-uumpisa yung mga methods na kailangan natin gawin to solve for the material balance. So umpisahan natin sa extent of reaction method. Okay, so for you to be able to use the extent of reaction method, kailangan you have to set up the extent of reaction equation. So kung naalala nyo pa, we have to go through it one by one sa mga compounds natin. So unahin natin yung formaldehyde. So CH2O si formaldehyde, right? Okay, so naalala nyo well, let me probably write first yung ating extent of reaction formula. So kung naalala natin, N, okay, anong subscript yung ginagamit ko dito? Let's probably use Ni lang. Ni meaning yung final moles nung particular substance na yon equals NiO, initial, plus extent of reaction times the stoichiometric coefficient. Positive pag product, negative pag reactant. Okay, so continuing, start natin sa formaldehyde. Okay, so formaldehyde is N1 equals initial moles ni formaldehyde. Well, wala tayong pinasok na formaldehyde, so 0 siya. Plus extent. Now, anong extent na yan? Dalawa kasi yung reactions, therefore there will be 2 extents of reaction. So check natin si formaldehyde, nasan ba siya? Okay, so reaction 1 or reaction 2? So formaldehyde participates both in reaction 1 and in reaction 2. So in reaction 1, formaldehyde is a product, while in reaction 2, formaldehyde is a reactant. So therefore, extent 1, meaning reaction 1, times product siya dun sa first reaction. So therefore, positive. 1 being the stoichiometric coefficient. In the reaction 2, so meron siyang extent 2, ang kanyang coefficient ay 1 din. Kaso gawin natin negative kasi reactant siya dun sa reaction 2. Okay? So simplifying this a little bit, N1 therefore will be extent 1 minus extent 2. Okay? Let's do it also for water. So next natin is water. Okay. Checking again so anyway, water is, ang symbol na ginamit natin sa kanya is N2. Meron ka bang pinasok na water? Wala rin. Now, plus yung extent 1. Extent 1 times, tignan natin. Si water, ganoon din. It appears both in reaction 1 and reaction 2. Pangalawa, water is both a product sa parehong reaction. Okay? So ang coefficient ni water dito ay 1 for both reactions. So therefore, extent 1 plus extent 2. Okay. The next species is carbon monoxide. Carbon monoxide gets N3, right? Wala tayong pinasok na carbon monoxide, guys. And si carbon monoxide, it only participates in the second reaction. It's a product in the second reaction. So, plus extent 2 lang, times 1 being its coefficient. Next is methanol. And methanol is N4 equals, meron ba tayong pinasok na methanol? Meron, 100 moles. Yun yung basis natin, right? Minus, plus rather, extent of reaction. Methanol only participates in the first reaction. Tama ba? So, double check natin. Yes, sa first reaction lang siya makakita. Coefficient niya is 1, pero negative kasi reactant siya. Times negative 1. So, gawin na lang natin minus extent. Okay? Dalawa pa, si oxygen muna. N5. Ano ba ang pinasok natin na oxygen, di ba? Fed oxygen is 100 moles minus, okay, following the same pattern, ganito yung magiging extent equation ni oxygen. 1/2 extent 1 minus 1/2 extent 2. Why? Kasi oxygen is both, it's found both in reaction 1 and reaction 2, and pareho siyang 1/2 yung coefficient niyan, pareho ring reactant si oxygen. Si nitrogen, which is our tie component, N6 yung kanyang symbol. Well, alam na natin yan eh. Kasi ang pinasok na nitrogen is 376, right? 376, na-compute na din ito kanina. 0.9 moles of nitrogen. Okay? And it does not participate in any of the reactions. So, wala na. Tapos na yan. Therefore, another unknown ang ating na-solve. Not really solved kasi basically nitrogen is a tie component. Whatever nitrogen goes into the process, ganoon din naman yung lalabas dun sa process. So, tatlong unknown na lang, by the way. Okay? Saan natin hugutin yung tatlong unknown? How do we solve it? Well, ang maganda dito, doon sa mga extent equations natin, so sabihin natin, umpisa natin sa methanol. Nasaan si methanol? This one. Okay. Eh, di ba kanina na-solve na natin tong N4? Tama ba? So, N4 is 10 moles. Okay, so considering methanol, again, N4 is 10. So therefore, extent 1 is 100 minus 10, which is 90. Okay. Now, how about yung yield kanina. Di ba? Nakuha natin yung N1 as 75 moles. So, nasan ba si N1? Na kay formaldehyde. N1 equals extent 1 minus extent 2 daw. So, si formaldehyde, kung babalikan mo yung kanyang extent equation, di ba? N1 equals extent 1 minus extent 2 daw. Pero sa N1, nakuha natin yung kanina from the yield, di ba? That's 75 equals extent 1 is 90 minus extent 2. So therefore, extent 2 will be equal to 15. Since meron na tayong extent 1 and extent 2, we'll be able to calculate the rest. Okay? So, halimbawa, si N2, sabi natin kanina, si N2 ay extent 1, sorry, not N2, but tama. N2, which is for water, no? For water, N2 is extent 1 plus extent 2. So, kinupya ko lang yung equation niya dun sa taas. O, di makukompute na natin yan. Extent 1 is 90 plus extent 2 is 15. So, therefore, N2 will become 105 moles of water. Okay, next, yung kay carbon monoxide naman. So, kopyahan natin ulit yung carbon monoxide, yung kanyang extent equation ay N3 equals extent 2. Eh, ang extent 2 is known na siya sa atin. So, N3, therefore, ano ba yung extent 2? Diba 15 moles. So, N3 is 15 moles of CO. Okay. So, ano pang kulang? We have N3, we have N2, we have N1, we have N4. N5 na lang. Ano ba yung N5? N5 is oxygen. Yung kanyang extent equations, N5, kinopya ko lang, 100 minus 1/2 extent 1. Alala nyo? Minus 1/2 extent 2. Substituting yung alam nating value na extent 1 tsaka na extent 2, therefore N5, you'll be able to get 47.5 moles of oxygen. Okay, so we have completed the unknowns. Let's just summarize a little bit. So, product composition. Formaldehyde, water, carbon monoxide, methanol, oxygen, nitrogen. So, yung mga nakuha nating moles, okay, ay ang mga sumusunod. So, N1 is 75. Okay, si water, which is N2, that's 105. Si carbon monoxide, that's N3, 15. Si methanol is N4, that's 10. Oxygen is N5, and that is, we solve it na, ilan? 47.5. And finally, si nitrogen is 376.9. And then you can calculate the percentages, okay? If you want. So yan yung ating product composition in terms of moles. So that is your extent of reaction method. Now, let's try solving this same problem using atomic balance method or elemental balance method. So letter B. Elemental or atomic, no? Balance. Okay. What I will do is I will copy the flow chart para hindi tayo mag-scroll na mataas masyado. So, let me copy this. Yan. Okay, so we'll solve the same problem, but we don't have to go, we don't have to compute for the other given, no? Kasi tapos na yun kanina using the, dun sa discussion natin under extent of reaction method. So, kung maalala ninyo, na-solve na natin si N1, which is 75 moles of formaldehyde, and si N4 is 10 moles of methanol. Okay, kasi masosolve itong mga to using the given conversion and yield, right? So, tapos na itong N1 and N4. Tapos, alam din natin yung amount ni moles of oxygen fed. So, we know that to be 100 moles. And yung moles ni nitrogen fed, we know that to be 376.19 moles. Okay? So, the rest of the unknowns, let's find them using atomic balance method. So, paano nga ba yung atomic balance method? Now, basically, you will balance each atom, okay, one by one. So, para ka lang na non-reactive balancing. So, umpisa natin sa carbon balance. So, for carbon balance, okay, ilan ba ang carbon na pinasok natin? Di ba 100 moles yung basis natin? 100 moles times 1. Kasi isa lang yung carbon atom kay methanol. Okay? Equals. Anong mga species dun sa product ang mayroong carbon? So, si formaldehyde mayroong carbon. So, N1 times 1 carbon atom. So, N1 times 1. Okay? Ano pa? N3, right? N3 times 1 din. Ano pa? N4 also times 1. Yun lang. Okay? But, we know what's N1 and we know what's N4 kasi nakuha na natin sila from the yield and from the conversion. So therefore, ang unknown na lang dito ay si N3. Okay? So therefore, N3 is equal to, substituting N1 and N4, right? N3 will be equal to 15 moles of carbon monoxide. So yan, kuha agad yung N3. Next is hydrogen balance. So isa-isahin mo lang yung mga elements. Okay, so 100 times ilang hydrogen sa methanol na pinasok, di ba? 4. Okay, and wala na, hindi mo rin siya makita si hydrogen sa air. So doon tayo sa left hand side, N1 times 2. Bakit? Kasi kung babalikan nyo yung flow chart dito, si formaldehyde mayroong dalawang carbon atom, hydrogen atom. So N1 siya. Ano pa? Kay N2, dalawang hydrogen. Kay N4, 4 na hydrogen. So you'll have 4 terms in the right hand side of the equation. So sulat ko na siya. N2 times 2 hydrogen atoms plus N4 times 4 hydrogen atoms. Pero teka, alam na natin yung N1, tama? Alam din natin yung N4, parang kay carbon balance lang. So ang unknown na lang dito is si N2. So therefore, N2 is equal to, if you will use your calculator now, 105 moles of water. Okay? Next is oxygen balance. May oxygen ba kay methanol? Meron. Ilan? Isa lang. How about kay air? Di ba 100 moles yung pinasok nating oxygen, tapos dalawang oxygen atoms yun. Kay nitrogen, wala syempre yung oxygen atom. Equals, saan yung mga species doon sa product side ang mayroong oxygen? So we have for N1, N2, and N3, meron din sa N4, meron sa N5. So 5 terms. Okay, mahaba. So writing them down, isa-substitute ko na yung given. So N1 is 75, right? Times 1. N2 is 105. Ito na-compute natin dito kanina. Times isa lang yung oxygen atom niya. Plus N3 is 15. Times isa lang yung oxygen atom. Plus N4 is 10. Isa lang din yung oxygen atom. Plus N5 is, ito yung unknown. Wala pa. Times 2 kasi dalawa yung oxygen atom doon sa oxygen. So therefore, makukuha natin yung N5. N5 is equal to 47.5 moles of oxygen. Okay. Isa na lang natitira, pero alam natin yun yung nitrogen balance, right? So if you will perform nitrogen balance here, N6, okay? Kasi N6 yung symbol niya. Times 1. No, not times 1, times 2. Tama ba? Kasi nitrogen is N2. Equals, sa product side, sorry, let me just correct this one. Not N6 kasi N6 sa right-hand side yun. Yung pinasok na nitrogen is 376.19 times 2 kasi dalawang nitrogen atom. Now, sa right-hand side, sa product stream, N6 yung symbol niya, times 2 kasi dalawang nitrogen atom. So therefore, N6 is basically just 376.19 moles of nitrogen. Okay, so if you check the values for this calculations, so we have N3, N2, N5, and N6. Parehas ba sila dun sa unang method? Yes. So pare-pareho lang sila. Okay, dun sa extent of reaction method. So we obtain the same answer. So please check. Okay. Lastly, let's also try using molecular balance method. So check natin kung parehas lang yung makukuha nating value ng mga unknowns. Just remember, no, na we already have N1, 75 yan. We already have N4, which is 10 moles. Okay, and we all know kung ano yung pinasok natin, oxygen, nitrogen, etc. And we also know the reaction. So if we perform molecular balance now, so starting with maybe let me probably write yung equation muna natin. Remember, no, it's input plus generation equals output plus consumption kapag steady state, walang accumulation. Okay, so umpisa natin sa methanol. For methanol, May pinasok ba tayong methanol? Di ba yun yung basis nga natin na 100? Plus, generation ng methanol, meron ba? So wala. Methanol is a reactant in the equation or in the reaction, but it's not a product, so zero. Now, output ni methanol, okay, ilan? Di ba si methanol yun yung ating N4? So therefore, meron na tayong value niyan, which is 10. Plus, consumption na lang ang matitira, which is unknown. And con. Okay. But there should be a value for this kasi methanol is a reactant nga in the reaction. Okay? So therefore, solving for N-con, moles consumed for methanol, okay, it's 90. Okay. Puntahan natin yung reaction, di ba? Methanol, oxygen, forming formaldehyde plus water. Okay? Now, na-compute natin kanina lang si methanol consumption, so 90. Ibig sabihin na yan yung pinasok na methanol. Siya lang yung na-consume daw. Okay? Kasi di ba 100 moles yung pinasok natin na methanol, so probably yung 10, so, okay? Which is tama naman kasi yun yung na-compute natin yung N4, which is amount of methanol na sobra. Anyway, for oxygen, kung alam natin yung 90 moles na yan from methanol, doing the stoichiometry, so 1/2 yung stoichiometric coefficient niya, so 1/2 of 90 is 45. This one will be 90, and this one will be 90 as well kasi 1:1. In other words, 90 is the moles of methanol consumed, 45 is the moles of oxygen consumed, 90 is the moles of formaldehyde generated, and 90 is the moles of water generated. And you can use that later on sa iba pang balances. And again, reminder that this is just for reaction 1. Okay, so continuing, after methanol, okay, sunod natin yung iba. So kahit ano pwede mong unahin. But let me go with formaldehyde first. Pinasok na formaldehyde, 0, wala. Okay, generated formaldehyde, meron dapat. Kasi if you go back to the equation, di ba ito yan? Meron siyang na-generate na formaldehyde. So N gen 1. 1 referring to the first reaction. Okay? Equals output ni methanol. Ano ba yung kanyang symbol? Yung output ni methanol. New formaldehyde rather. Di ba? N1 yung binigyan natin sa kanyang variable. Okay? Plus consumption ni formaldehyde. So meron ba yan? If you check the saan na ba yun? Ito na lang tayo sa pinakataas. If you check the equations, formaldehyde again is both a product and a reactant. Product siya kay reaction 1, reactant siya kay reaction 2. So kay reaction 1, meron tayong moles formaldehyde generated. Kay reaction 2, meron tayong moles formaldehyde consumed. Okay? So sulat natin. Plus N con consumed, no, na formaldehyde, pero kay reaction 2 siya. Hindi siya kay reaction 1. Okay, so simplifying this a little bit, yung engine 1, alam na natin yan. Kasi this is reaction 1, itong nasulat ko kanina. And we know na ang generated moles of formaldehyde is 90 from that given values above. Equals N1. Si N1, we know the value, right? N1 is 75. So ang natitira na lang is N con 2. Okay? So yung N con 2 na yan, since second reaction siya, 2 meaning second reaction, ano ba yung second reaction? Isulat natin ulit yung second reaction. Okay, so the second reaction is formaldehyde plus O2 forming carbon monoxide, tama ba? Yes, and water. Now, na-compute natin kanina lang yung consumption 2 ni formaldehyde. So ito siya. Sorry, hindi pa pala natin nako-compute. Sulat natin. N con 2 therefore is, ilan yan? 15, tama ba? 15. So, yung 15 moles na yan, na consumption ni formaldehyde sa reaction 2, dito siya. So, kung 15 yan, edi 7.5 tong kay oxygen, just doing the stoichiometry, right? And then 15 to, 15 din to. So, itong mga to, magagamit mo na to later on sa iba pang balances. So, ang ibig sabihin lang yan, in reaction to 15 consume, 7.5 moles ang consume na oxygen, 15 moles generated carbon monoxide, and 15 moles generated H2O, again, for reaction 2. Okay, so we're done with the methanol balance and the formaldehyde balance. Let's complete the balances. Sunod natin siguro water. Okay, so water balance. Pinasok na water, wala. Generated na water, meron ba? Meron. Saan? Ayun, no? Product siya both kay reaction 1 and kay reaction 2. So 90 plus 15. Okay. 90 plus 15 equals output ni water, it's the symbol is N2 plus consumption ni water 0 kasi water is not a reactant in any of the two reactions. So therefore N2 is equal to 105 moles of water. Ayun, no? Nakakuha na tayo sa wakas ng isang unknown. Okay. Next is carbon monoxide. Pinasok, wala. Generated, generated carbon monoxide, meron ba? Just look at the reactions. Product ba siya o reactant? Product. So generated siya. And we know the value, which is equal to 15. Okay. Equals output carbon monoxide, N3 yung kanyang symbol, right? Plus consumed carbon monoxide, hindi naman siya reactant in any of the two reactions. So therefore N3 is equal to 15 moles of carbon monoxide. Okay. Next, oxygen balance. Pinasok na oxygen, di ba 100? Plus, is oxygen generated in any of the two reactions? Wala. Oxygen is not a product in any of the two reactions. Equals output of oxygen, that's N5. Okay? And consume oxygen, dalawa yan dapat kasi for these two reactions here, oxygen is a reactant kay reaction 1, reactant din siya kay reaction 2. So pareho na may consumption ni oxygen for both reactions. Eh, ilan naman? Yung isa 4.5, yung isa 7.5. 4.5 plus 7.5. So therefore, N5, you will get that to be 0.5 moles of oxygen. Okay. And last na lang, nitrogen balance. Pinasok na nitrogen, meron ba? 376.19. Meron bang generated na nitrogen? Wala. Equals. Output ni nitrogen, it's having the symbol N6. Plus consume nitrogen, wala. Kasi nitrogen does not participate in any of the reactions. Therefore, that's already your nitrogen. Okay. Moles of nitrogen. There you go. We have completed the balances. Now, if you are going to check yung N6, N3, N2, ano pa ba? And others, okay? Parehas lang ba sila dun sa na-compute natin kanina? Yes, N6, N5, N2, N3, dun sa ibang methods. So, That's how you solve material balances involving reactions utilizing the three methods. So it's up to you in our exams or problem sets. Some of them I will require you to solve using all methods. Yung iba naman kayo bahala kung anong gagamiting method. But here's the thing, yung ating molecular balance method or species balance method, siya yung method na pwedeng makapag-solve ng kahit anong problem. Unlike si atomic balance at extent of reaction, there are some problems that you cannot use these methods because of the nature of the resulting equations. Pwede kasi maging dependent equations sila.